Okay, to people joining this live stream, this is a fairly late stage in our molecular structure and computation capabilities for version 12. We're looking at documentation. We're talking about some final design issues. Okay, so these things here, what is molecule display options? What is that?
Right, so that's that'll be the option for molecule plot and molecule plot 3D, where we would hide, where we would put all of the specific string valued options that will in the future be what controls a plot theme. So things like
I don't think that's the right thing to do. Why don't we have that be a method option for now?
Okay, yeah. So molecule plot 3D and molecule plot will both take method and goes to, and then you can give it an association with all of these things, are like double bond offset, which controls how far apart to put the lines for double bonds and stuff.
Yeah, I think that's the right thing. Michael, do you object to that?
No, actually, Jason and I already had this discussion as an option to just shove it into method.
Okay.
Right. Yeah.
Fine. Okay, let's get rid of that then.
So one thing that's new there is the option for molecule aromatic bonds. It doesn't work in today's build. I'm currently making it work. But the idea there
Wait a minute, that's an option.
Right. So because a bond can be one of single, double, triple.
Wait a minute, so atom coordinates, okay, is an option. Right. You're gonna de-experimentalize. I mean, defuturize these things, aren't you?
So should they all be? I was under the impression you had to specifically say that each one is good before it had to be.
So that's why we have this meeting today, to clarify this. Yes.
Okay. All right. Okay. Well. All right. Fine. Okay.
But yeah, I can defuturize them and then DQ.
I don't know why this is. Whether to detect bonds. What does that mean?
So when you enter a molecule such as benzene or anthracene, we can either keep it in one of the two forms with the alternating single and double bonds, or marking the bonds as aromatic.
Okay, so show me. So if I say molecule, what's the smiles for? Well, if you say benzene or something, right? Okay.
And so if you look at its bond list, they will all be marked as aromatic.
So how do I get the bond list? Do I just say input form?
Yeah, or bond list is a symbol. Right.
Okay. Fine. So what's your point? So what would the issue be?
Right. So some people might want that to be always in the form of alternating single, double, like localized bonds.
Okay, but that's not the good option name for that. I mean,
so it seemed less of, let's see, so you might call it keculize, which kind of means the opposite. But
okay, hold on. The name, when you say include hydrogens, that's, so for example, if I were to say here, that thing there, include hydrogens arrow false. Well, how would that affect this structure?
So the input form would be much smaller, yeah. But everything,
right.
so
okay. So
semantically,
I think this is a similar kind of thing. And I think what it is, it's more like.
So the aromatic should be made a verb.
Right, like detect aromaticity is one that I thought about, but
aromaticize bonds.
No, but why are we just saying include aromatic bonds?
Because I feel like it's more, there's a detection involved. If you enter it in as single double on a benzene, I would like to be able to detect that after you enter it and change them if the setting is set to true. So it's
change them to aromatic.
Right.
How about aromatized bonds?
I think it's really weird. I think it sounds, I mean, it sounds faintly romantic or something.
I was trying to get away from keculize.
Yeah, that's awful too. I mean, given that we're calling this aromatic. Okay, so let's walk through what this really is. So what we want, Did I write this or did you guys write this?
You did initially, and I added structure diagram coordinates and aromatic bonds today.
Okay. It's good, by the way, to when you do add things to put them as tentative so we know what's added and what's not.
Okay.
Okay, so let's read through this. Whether to implicitly add hydrogen atoms for unfilled valences. Okay, so no, that's not right. Explicitly specify 3D coordinates of atoms in a molecule. Explicitly specify 2D coordinates to use in diagrams, because they're not real 2D coordinates, if you understand what I'm saying.
Oh, absolutely.
Right?
Yeah.
Because those are not really analogous.
Right, and it's so that's why atom coordinates will always return a quantity array, because they do have a
What do you mean by return a quantity array? What are you talking about return? No. If you're going to do that, you cannot do that. You cannot have the option also be a function.
Right. No, that's not what I meant. There is a property with the same name as the option.
Okay. All right. Okay. And there's presumably a property with the same name as this option.
Yes.
Okay. And so this one is in quantity array, and this one is in some kind of literal in some kind of just numerical coordinates. Is that correct?
Yes.
Okay. Okay. So this one is. So if I put in here aromatic bonds arrow false, what would it do?
So if it was hooked up, like in my local build,
yeah, I would say single double.
Yes.
Okay. Why don't you just call it use aromatic bonds?
Use is a relatively uncommon construct in our world.
I know.
I tend to think of it as marking them, but I don't know if that's the right verb here either.
No, we're not really
documented function that has such a name.
Okay. Well, we've got include, but we don't have.
How about enable aromatic bonds? I think we use enable elsewhere in the language.
Yeah, we do, but I don't think that's very good either, because it's not a question of enabling. It's a question of whether. Okay.
Form.
How about aromatic bond rendering? It's not really.
It's not about rendering. It's about what's in the input form.
Well, it's all what it is. It's bond localization, right? So you can say bond localization is true or false.
I think you need aromatic there, unless there's other cases like
aromatic bonds.
Hold on. Are there other things like aromatic bonds? I mean, or is that chemistry is so frigging full of these special cases? Okay. Are there?
So that's all I can think about. So these are things that I need to know when I'm constructing the molecule, and so I can't think of others at the moment.
Okay, so include. This is very similar to the include hydrogens business.
Right.
Something that'll come up in the future will be dative bonds. So we need to come up with a way to handle both types properly.
What is the question for dative bonds?
We're going to handle dative bonds in the future, post 12.
I understand, but what will be the handling of those?
Well, they can be represented as charge separated double bonds in structures such as in sulfuric acid or sulfones, and
but they wouldn't be something that we would detect in the structure. That would be something that the user could enter, and then we would allow them, or I mean, we would know what to do with that in the future, is what I mean to say.
Yeah, but there's the single bond with charge separated or double bond or dative bond representation.
Right.
I don't know what that. I'm sorry, guys.
Yeah, that's why we put it off till after.
No, but I don't know. What would this then look like?
Okay, instead of S double bond O, it could be S with a double plus charge, a single bond to each oxygen, and each oxygen have a negative charge. That's one representation.
I see.
The third representation is with a dative bond, which is rendered as a long arrow with a cross on it, basically representing a plus sign on the end.
So this is another. Is this another? Would that affect the internal structure of this or not?
It does not affect the structure. The structure, the electron positioning, the Lewis dot diagram does not change.
Stephen means the structure in the sense of molecule arguments, not.
It would be.
Yes.
It would not change the structure other than we could use quote dative quote for the bond instead of quote double quote.
Great. So it does affect the structure.
Yes. Okay. So yes, it does.
Okay.
Language structure, yes. Chemical structure, no.
In general, it's something that would have to come from outside, like they read in a mol file that has dative bonds in it, or they enter.
Well, or couldn't we detect it? Can't we detect this case?
Yes, we can, just like
in the aromatic. Right. Fine. So,
so that's not something I'm familiar with any other toolkit doing. So let's see.
But
so
clearly it's possible in principle. So,
but it's only a matter of we want to not need a whole bunch of new words for this.
Right. That's the point. That's what I'm just saying. You know, I don't like this term, but auto-detect bonds. That's awful. But you get what I'm saying.
But it's not a matter of auto-detect, like kind of which viewpoint to take.
Right, I understand. So
it's localized bonds.
Or localized aromatic bonds, if you want to make it.
But it's not aromatic specifically. We're talking, we want to combine the dative and aromatic cases.
How about an option called special bonds, and the right-hand side could be aromatic, dative, a list of things to be handled in a special way.
Yeah, we don't
something like that, or none, which means we don't do anything.
Okay, I like that general idea, and then we could say, I mean, I'm favoring. It's not quite the word rendering. What is the bond interpretations?
Yeah, interpretation is probably appropriate.
So interpret bonds might be a cue to
well, how about bond interpretations? Bond interpretation.
Would not representation be better because it's reflected in the result?
Okay. Representations. Bond representation types. And then we can say, because I can imagine you're going to want to do this for, I want this aromatic bond. I've got some crazy molecule with six of those little hexagonal thingies, right? But I want one of them represented. Could that happen? One of them represented, aromatically, and the other decaculized, or whatever the term is.
I can't imagine what you would want it.
No, we wouldn't do that. It would be all or none.
Okay.
And I want to reemphasize that I don't think that it's all that. Let's see. I don't think dative is something to even bother about at the moment. I don't think that this is a special case. I've been doing this for about a year, and aromatic is.
All right, so what about aromatic representation? Aromatic, which is, and that's true or false. You either use the aromatic representation or you don't.
Yeah, that works.
Yeah, that'll handle this case now, and then we'll just have to deal with something for dative bonds later.
Okay.
And if it's enough of a corner case, we can just ignore it. I mean, I've come across it in the past.
Right, and I mean, generally, I don't know. So let's see. If detecting and marking bonds as dative is something we want to do, that's always something that a molecule modify can do.
Yeah, so we'll worry about it later. But
okay.
This case here.
But this is important because patterns, when doing substructure searches, it's all over. it's very common to mark to look for
Okay,
aromatic.
aromatic representation. How to represent bonds, whether to use aromatic representation. Is that right?
Yeah.
Could also be allow aromatic bonds or include aromatic bonds. What do you want to do? Allow aromatic bonds, include aromatic bonds. Why not include aromatic bonds? I mean, if you don't include aromatic bonds, it means you're going single double. And that would be very analogous to include hydrogens. Seems better to me.
So I'm not really.
The bonds will be there regardless. It's a question of the type of bond that's there.
I know, but it's like include aromatic bonds as opposed to use only single and double bonds. That would be my argument.
So I'm not opposed to that. It is clear what it does.
Okay, then I prefer it. Include aromatic. Whether to include aromatic bonds or to keculize. Is that correct phrasing?
Usually we say we use the keculized form.
Okay, whether to include aromatic bonds or use keculized form.
But then we did run across the point that there's a large percentage of the chemistry community that doesn't even know what that word means at all.
Then I think using localized bonds would be better, or localized single and double bonds, but that might be too long.
All right. Whether to include aromatic bonds or use
I think localized
single
form.
double form.
Yeah.
Okay.
Yeah. Leave it that way. That'll be fine for here.
Okay. Okay. So we need a rename on that page. Yeah, I'm gonna assume. Well, I'll just do it. It's easy to do. Okay. Okay. All right. So here I think we can what are some typical plot themes that are useful?
Right. So I have only 3 plot themes set up for molecule plot 3D, which are essentially the ones that have been used in chemical data.
What are they?
Space filling. There's ball and stick.
Okay. Specify. Overall rendering. Overall.
Appearance.
Yeah. So now, and then I want to put in parens. Say what some of them are. Space filling.
So
Is that correct?
Yep.
Space filling.
Ball and stick.
Ball and stick like that.
Yeah. You've got so
wireframe is one, isn't it?
Yeah, wireframe.
Okay, we can do ... at this point.
Yeah.
We just got to give people some idea. Those two are obviously useful.
Right.
I wouldn't mind a better name for. So my favorite plot theme, I couldn't come up with a good name for it because it's called stick plot.
What does that mean?
So it's like the ball and stick, but I take away the balls.
Isn't that just wireframe?
No, so wireframe uses line, and
okay.
Stick plot uses
tubes. So okay.
Okay. Well, hold on a second. So stick. bond sticks or something. I mean, I don't quite know what these names are connoting, because they're basically space filling it's just the atoms.
Correct, with van der Waals radii, and they look like a bunch of bubbles stuck together.
And so stick plot is what we came up with when we exposed it in entity value.
Is it the default?
It's not, just for continuity. But so I'm talking with design, and we might decide to make it the default. I'm not sure.
Well, so let me understand what this is going to do. So if I say, okay. By the way, did we fix the crazy spherical regions and things?
Right. So I wanted to verify. I actually really like the spherical region goes to sphere. I have not set it on molecule plot 3D, but
well, no, but it needs to be the min ball, right? Not the sphere is being set. The issue is, does spherical region...
No, you misunderstand, Stephen, as always.
Okay.
There is a setting now for spherical region where you can give it a sphere. Okay.
Okay.
But what
is it only this specific thing I always misunderstand, or is it more general? Specific one.
No.
I know it's the specific one. Go ahead.
Okay. No, but this particular thing has come up in so many variants.
I know it has. So why don't you explain it once and for all, so I actually understand it?
So what can happen is that Graphics 3D can take an option for spherical region that is an actual sphere. Okay.
Which just includes all of its objects.
Well, you have to specify that. It will just use that sphere, period.
Okay.
Okay. So for a function like this, we can use minball and other things to compute what the actual sphere is to give it.
Okay.
That's what needs to happen from molecule plot.
I've in my tests I really like the way that looks, and so I just wanted to make sure that that's a good thing for me to do in this built-in function, is to set it to that.
Yeah, it's still going to be automatic, you see, right? So because that's going to be derived from data, so you can't give it a specific thing. Doesn't make sense.
Okay. Okay, so but this is not, you have not set that in this case.
Correct.
Correct.
Roger, to be clear, so like the value in the molecule plotters is automatic, but in the resulting 3D graphics, it's explicit.
Exactly.
Okay, good. Just that we don't have a misunderstanding.
No.
Okay, by the way, you've got to fix this autocomplete. That autocomplete is obviously silly.
Right, I'll talk with Tom about how to do that for molecule plot 3D.
Jason, do we have
like a dog? Okay, go ahead.
Jason, do we have plot themes for molecule plot, the 2D version? We had talked about using different journal themes.
Right. No, I mean, so
I think you should go further. Post this release, I think you should look carefully at useful there.
Okay.
And I think it will grow.
Right. So for this release, the idea is that I will just have all of the method options that will allow people to make the plot themes, and then in the future releases, we will really make some nice ones.
We'll bundle them. Okay.
Yeah. It could be that some of them use labeling schemes, for instance, and then you have a project to do labeling right too.
Right.
But I could see that people would appreciate that.
Yeah, I've been talking I spoke with Min at the conference about setting up call outs and all that, and so that's what we're really gonna think about.
Yeah, I think that would be not always, but for it's clearly a useful thing.
So we still have to talk about the molecule pattern. Right? This is somewhat.
All right. Okay.
Right. Yeah. So do we have an opinion, since we're all here, about which of those should be the default?
This one.
Okay.
I think it's too obscure to have this one be, but I think these names.
The names have continuity with chemical data, so. and with all of the imports. So in the past, you've been able to import a
I think ball and stick is a good name because it
I
comes
agree.
from kits of balls and sticks.
And
Right.
they're used in the field like since forever.
Yes.
Are these things called pipe cleaners or something? What is this last one usually called?
Why I usually hear it as wire frame, even though we're using cylinder here with caps on the ends.
So would we call it thick wireframe, or it's not quite? But if you want to look at wireframe, it really is just lines. It's useful when you're looking at larger structures.
Yeah.
Maybe that could be an option.
Sorry, not really, because for lines you lose most of your 3D feeling.
Yes. Well, except you might get 3D from the size of the structure.
But extremely thin cylinders might actually give you a better feeling.
But I assume that they're going to be themes that sort of kind of aggregate whole chains of atoms together, like you do for proteins and other things.
Possibly. Okay.
Yeah.
Look, stick plot is clearly not a winning name because it's a different character of name than all the others.
So I could reach out to Jeremy and ask about.
He's not going to. I mean,
He's not going to have an opinion about.
I just meant design. I'm sorry.
No, a design is fine.
I think tube or cylinder or some name that uses those phrases would be good for this one.
How about like bond tubes? Or is that too utterly obscure? How about tubes?
Or just tube, maybe. I mean, ball and stick is singular.
Mm-hmm.
I think it should be tubes, plural.
Okay.
Ball and stick is an adjectival form, and I think this is more. I mean, unless you called it tubular.
Totally.
It reminds me of a 1970s album.
Tubular bells.
Yes.
Yes.
Yeah.
Right. So if someone did plot themes and then arrow, and then they had autocomplete for ball and stick or tubes and wireframe, I think it would be clear what they.
Yeah, I think so too.
Yep.
Okay.
But you could call it skeletal model, but this probably.
Call it what?
I think they call it skeletal formulas.
Skeletal?
Yeah.
Yeah. We'll leave that for anatomy plot.
Okay.
Okay. All right, let's keep going.
Let's see. So the big thing that I wanted to verify before Monday is molecule pattern. I've heard from many people that it's confusing because it's not a Wolfram language pattern and it doesn't invoke the Wolfram language pattern.
What is this fixed valence thing?
So that would be an option for molecule modify, kind of a catch-all. If it's true, then we try and do the right thing. We add hydrogens, remove orphaned hydrogens when you created a bond and left them behind. If you if you delete a bond in an aromatic ring, I'll first convert it to its delocalized form before doing that.
Okay, I think it's a good concept, a bad name.
Okay, so I was using the string valence handling, goes to true or false.
Why isn't this a function for other things as well? I mean, why isn't it the case that when I specify a molecule, I mean, just here, right?
So I'm not opposed to, in principle, fixing the molecule when you create it. I just don't have that implemented yet.
I'm also not such a big fan of this because there you might get something you didn't want. Originally, you should get kind of verbatim what you had.
Isn't there a way of specifying something? I see. So right now, include hydrogens just says any place you've got hanging bonds, stick a hydrogen. It's very hydrogen centric. Is that right? I mean, is that what you're saying? Basically, right now, if you've got a bond hanging off, whereas what does this do? I mean, if you've got a bond hanging off here, why doesn't it add a hydrogen? Because what this is doing is it's assuming that there are no new atoms. Is that correct?
Let's see. So molecule modified. So when you add a carbon atom, fixed valence would tell you whether or not to include the hydrogens, but it also tells you when you create a bond between two atoms that already have hydrogens, it tells you to get rid of them. But some people might want to do it all manually and be left with an invalid valence state for the time being in between.
Right, and the other way of fixing them is leaving the hydrogens there, but then changing the charge on the heavy atom, incrementing it, for example, to make CH5 plus, which is a valid ion in the mass spec.
Okay, so fixed valence just doesn't seem right. I think your valence handling seems like a better idea. And then you can specify a variety of things to do. I also think you probably need a molecular. Oh gosh, what really is it? What you're really doing is, it's auto repairing the molecule after you modified it somehow.
Right.
And so presumably in the future we might have a function called repair molecule, like repair mesh.
Mm-hmm. Molecular repair handling. It'll make people think it's an anti-aging serum. What is this really doing? What are the settings for this thing?
For the fixed valence, so right now it's just automatic or false, right?
Okay.
But then,
well,
so if it were valence handling, then presumably you could have take an association on the right-hand side also.
Yeah, which tells you what to do. But is it just valence?
So it's valence and dealing with aromatic structures, and so removing what I think of as orphaned hydrogens. And so I had a string option name called remove orphaned hydrogens, but I think it.
Yeah. Well, so look.
It's really just the bonding that's being corrected. It's nothing to do with geometry.
Maybe, I don't know.
Because of the geometry, there are not easily implemented rules that could be done. It usually has to be corrected with an optimization method under some kind of force field or molecular orbital theory to do that correctly. For example, taking a carbon that's sp3 hybridized and making one of the bonds a double bond. It's now sp2 hybridized. It's got to become planar, and that's not something that's easily handled. So we only want to handle, in this scenario, the bonding, formal charges, and whether or not hydrogens get added or removed.
And I think valence is a term that's familiar enough to chemists and chemistry students, and you would say that molecule has valence errors or not.
That's generally what they're called, valence errors, yes.
Okay, so
fixed valence errors?
No, because we don't want to say fix. That
has multiple meanings. Repair, I think, is probably better. And if we have a precedent with repair mesh.
No, that works.
Right. I think that would be okay. Valence error handling. It's very specific.
But is handling good English?
Yeah, it's fine. And that then you can give it a bunch of different options later.
Right.
So this function has just tons of I'm not even sure we need to put this. Okay, so then where's the method? What's the method option going to do?
Right. So some of these. So let's see. So in particular, compute atom coordinates takes several sub options, like random seeding. It takes a max attempts sub option. That options that don't make any sense for delete atom.
Mm-hmm.
Right. So this valence error handling and method would be the only top level options for molecule modify.
I don't think we need to oh, all right. We can list this here, I guess. I don't think it quite is that important, but option whether to fix to balance valences. Is that right? Is that the right term? What do you use for what is the term?
I don't think balance is correct.
Okay, whether to repair valence structure.
Repair structural errors.
How about that? Okay.
Yeah.
Okay. Molecule pattern.
Right. So we want to call this molecule substructure. Just because it's not the Wolfram language pattern matcher that does something with it. We originally, or at some point early on, we had talked about molecule expression in comparison to string expression. But I like substructure because it's, let's see, we've already got fine molecule substructure. And in the future, we'll have maximum common substructure.
Okay, but so let's just think about that for a second. If this is called molecule substructure, let me remind myself what's actually in here. You can give a smart string, right?
Right. Or you can give a list of atoms and bonds.
I see. I see. So this is really, okay, but you can also have blanks in there, right?
Right.
And that's the thing that is like a pattern.
Right. You can, and alternatives as well. But each of these, I'm parsing them as a specific query in my library, rather than calling the pattern matcher.
To what extent is it, in fact, just like molecule, but with patternization?
Well, I'm using the same underlying data structure. I'm just not doing any valence checking at all. And so therefore things, you can have a pattern, a molecule pattern that consists of two aromatic atoms bonded to each other, which molecule will reject.
Okay, but isn't it the case that you go from molecule to molecule pattern by changing literals to pattern objects? Isn't that true?
Potentially, but they could stay literal.
like fully specified.
Like in the second argument of cases can be an explicit object.
Yeah, I understand, but I'm still trying to understand why people have a problem with the term molecules pattern, because the difference between this object and a regular molecule is that this can contain pattern pieces. Is that right? Or that this can contain non-valence correct things. Which is it?
So it's definitely both, right? It's that so it can contain. So in the pattern here, you can write atom S or atom atomic number goes to between 11 and 15, which wouldn't make any sense when constructing a molecule. So that's not the case of it being a valence error. It's so I guess so Itai is the one who mentioned that maybe I could find something different besides pattern. And every time I've shown molecule pattern to people, they wonder if that's the right thing to call it. And then finally, if you look at the doc page for bond list or atom list, the second usage is bond list of mol, comma, pat. And I feel like that has connotations in the Wolfram language for a documentation page when pat is the second argument. That to a lot of people that will imply that you need to give a literal Wolfram language pattern, which in the case of bond list will work.
But every expression is a Wolfram language pattern. Every expression in language is also a pattern.
Okay, who really objected? Is this Itai objecting to this, or is this something else?
You don't have many patterns in the language.
Right, so Bjorn has expressed.
Michael also didn't like it.
Right. No, I mean.
No, that's not true.
I feel like every time
that's not true.
I've shown it to anybody, they.
This is because most people think by pattern somewhere there must be blankish like objects.
Right, and it's more, it's closer to the entity value, like an implicit entity class, or it has a lot in common with that, with the structure of those queries. I think of them personally as query atoms, but that's not the right word.
Yeah, but substructure doesn't exactly capture that, does it?
No, in my opinion, not.
I mean, and substructure.
Like Jason and I discussed it's like in the future we want to have a fragment, and I feel like the discussion between a substructure and a fragment becomes actually quite tricky.
What is a substructure versus a fragment?
Well, so a fragment would be useful if so it's a fully formed molecule except for one dangling hair with an attachment point, and it's useful when you take two of them and you want to join them, and it's very easy.
It could have multiple hairs, but it's everything is fully specified that's there.
And so why is that not a subcase of molecule?
So it could definitely be. We don't have a full design for the fragment.
But pattern has things that are ambiguous so that it can be matched against multiple explicit instantiations. I personally like molecule pattern.
I don't see a problem with it. I mean, it seems like this is finding a substructure. See, this returns. If you said find molecule substructure, and there was a thing called molecule substructure, I would expect find molecule substructure to return the substructure. Do you get what I'm saying? Whereas it actually just returns a bunch of positions.
Right. Okay. So, all right. So I guess I needed to one last time verify that everybody's okay with calling it a pattern.
It seems like it is a pattern. It's a pattern that represents a class of molecules, a class of molecular structures. I mean,
I agree with this viewpoint.
Okay, so, all right, so I will refer Itai to this recording.
Fine.
Sorry, I was trying to inject some levity.
By the way, you should give an example with a smart string here.
Yeah.
Okay. All right. What else do we have to figure out here?
So I mean, let's see. Other than that, the only new thing I've added since the last time we talked, I added an operator form for molecule contains Q. Seems fairly uncontroversial to do so.
I agree.
Okay.
So if I wanted to find which molecule, let's see, I have a list of molecules and I want to know which one is the one I'm currently holding up, so to speak. That is just, I select with molecule equivalent Q. Is that correct?
Yes. So molecule equivalent Q doesn't have an operator form, so you would have to.
Yeah, although one could make it given an operator form. The only question is whether molecule equivalent Q would ever want to have a multi-argument form.
Right, I did set it. It doesn't say so there right now. I do have it like that because that's what isomorphic graph Q does.
To allow 3 graphs.
Right.
Right. So it's a little unfortunate that if you want to find out which molecule in some set, I mean, is it blind? You know, is it horrendously slow?
But it doesn't even work for equal.
Yeah, I understand, but you don't. I mean, if you want to know, okay, so the issue is really molecule cases somehow.
But wouldn't molecule contains Q, if this, what Jen just said, is operator formable, do the job because the thing is contained in itself? So you get a couple more that you don't want. Okay.
Yeah. Okay.
So if there were to be an operator form of molecule equivalent Q, I might want to make it. So it's set up right now. It has these string valued same tests as an option. It's an option.
What? What are you talking about?
So if you look at molecule equivalent Q, it has the option same test.
We discussed this.
Yeah, we did. That's fine.
Right. And okay, so right. And so if it only took 2 molecules, then that could be a third argument, and you would.
Yeah, I wouldn't worry about that. I wouldn't worry about that. I wouldn't look, what I would do right now, I would disable the 3 argument form of this. I would just silently not deal with it. You didn't document it, don't deal with it.
Okay.
And that way we have the possibility of changing our mind about how this works in the future.
Yep.
Okay. Seems great to me. Anything else for this? I mean, we'll. So there's. Or did you want me to try and go through? Hold on a second. Let me just look at what I'm colliding with here. Oh, this is the thing I'm not going to do. This was about doing some tweet. I'm not going to do it.
So I feel like we've agreed on the usage for everything on that page.
Okay.
And so if I defuturize everything, then DQA can start suggesting improvements.
You've got to say, are the same, represent equivalent molecules.
Yeah, that's.
It's a reordering of atom and bond lists that makes them the same. For which they're the same. for which they are the same. Reordering, I don't know, to make them the same. Doesn't this thing have the whole the whole kecular nonsense as well?
Right. I should add another string argument there, same test, which will perform the keculization. So the whole point of molecule needing to decide upon the construction of a molecule whether something's aromatic.
But then this isn't correct. If there's a reorder of atom and bond lists which make them the same, but up to something or other, right? By default, considered equivalent, right? That's the only case you're talking about there, because then this is, right? See what I'm saying? Because this overrides that.
Mm-hmm. Right. Yes.
But I mean, yeah, so there needs to be some more work here, I think.
Yeah, we know the dictionary is not perfect yet. It was mostly the function names before the freeze.
Yeah, okay. Okay, well, I think we're good there. I mean, are we going to go through and click through some of these? Let's take a look.
So there, obviously, I'll change the option aromatic bonds.
Yeah, it just becomes. I mean, just the changes to make that include aromatic bonds. And what's the ordering of the options listed here?
I'm going to change it to alphabetic.
Look, let me show you a most amazing featureoid. Have you seen this? Boom.
Yes.
There it is. Now it's alphabetic. Is that the most incredible, high-tech thing you've ever seen? No.
It's really an amazing palette.
Yes, it is. You could launch rockets with it. It's got so many options. Okay.
Yeah, no, there's something. Atom name, is that I kind of put off the discussion for that for the future.
Right, first was going to be specified. I don't know what that means. Oh God, what a mess. Okay, I understand that issue. Okay, beautiful. Okay. It's only a potential security risk if you actually get the atoms. Sorry. What does order mean? Bond order. But that could also be something other than bond type. Isn't that type
Right.
rather than order?
Yeah, I think that I'm remembering now you suggested type, and it went in one ear and out the other, apparently. So, right. So whether to allow a single argument form, we might need to just disallow that. So inside a molecule pattern bond with a single argument, I take it to be unspecified, but inside a molecule, I take it to mean single. And I think that's probably too confusing. And so we should probably just force them.
I don't think you should force them to put single in. Okay, that is too confusing as such. Yes.
So we could just make it always default to single, and if you want an unspecified, you either write the word unspecified or put a blank.
A blank, yeah. I would say so. I think that's more reasonable.
Okay, yeah. So then the last line on that notes
represents a bond with
represents a single bond, right?
This is what you have to do, right? Because there.
Right.
It can also be in molecule pattern. It can also be a pattern such as blank, representing any possible bond type.
Do you want to mention that it can also be in alternatives, or is that? If it can
Well,
be
that's what it says.
shown
It's
in
a
the
pattern.
document? Yeah.
Okay, now here I'm sure you want to say, in this bond thing, you'll want to say include hydrogens is one thing that surely is relevant here, isn't it? Because that's implicit bonds, basically.
Yeah, and then the new include aromatic bonds option.
Yep. I also think you should mention modify molecule here. Yeah, you got to say more in more detail here, and they include hydrogens. You've got to say in more detail what it actually does, what it means to, does it modify the structure? Does it not modify the structure? Does it include them in visualizations, etc.?
Right.
I think you also want to have. I would put molecule plots here and molecule plot 3D. They seem highly relevant to this, don't they?
Right. Okay, and so here's an issue. So molecule takes this include hydrogens, and so when it gives you back a molecule, it's either got implicit or explicit hydrogens. Now not every function, but many functions also, it makes sense for them to have the include hydrogens option. Right now, every function has the default setting true. Another way that you could think about doing that is to have molecule itself have the default option of true, and everything else is automatic, and everything else just.
That's what I would do.
So that's what Sean in QA, he thought that would be less confusing.
I think that's the right thing to do. So that way, include hydrogens sort of transfers over from the original molecule.
So then if you do atom count on a molecule that has implicit hydrogens, it will only give you the number that's in the first, or the ones that are explicit by default, unless you give atom count the option.
Well, yeah, unless you give atom count the option include hydrogens.
So I still would like the summary box to show. So perhaps show both, maybe with one grayed out in parentheses or something.
Why not?
So if there were implicit hydrogens, it would say atoms 52, comma 30, or no, not comma, in parentheses and slightly grayed out beside it.
Plus
30.
Or just plus 52 plus 30.
Okay. Well,
I mean, what I would do is plus 30 with the in gray and slightly smaller.
Mm-hmm. Right. Okay. So the
And you
explicit,
got that for bonds as well. It'll be bonds something plus something, right?
right.
For the atoms, it would be probably plus 30H.
Okay,
So
fine.
that would be good there. But for bonds,
Just say, once you said plus 30H, it's clear what's going on with the pluses.
okay, then the bonds would be just plus N.
Mohammed on the live stream points out the bond order that you can have 1.5, bond order 1.5 for resonance, which is the aromatic case, right?
So if you want to assign a numeric value for bonds in a bond weighted adjacency matrix, aromatic, you assign a numeric value of 1.5.
So arguably, when you say bond, when you give bond here, you should allow those to be 1, 2, 3, 1.5.
No. Let's keep the types.
Well, so it would be something that just evaluate. I mean, we could allow it and just evaluate it to the canonical form.
That's
that's something that Bjorn has been suggesting.
And what if somebody says 1.45?
Then you give an error message.
Well, there's polarization then also, which we haven't yet. Right? One polarization, which we don't support currently.
So polarization, I think, would be a property, a computed property on the bond.
Yeah, you're not going to say what the bond order is and include some weird polarization calculation that is affected by whether the thing is in, I don't know, stuck in solution in water and things.
So presumably, I'm going to hook it up to let a molecule pattern take rule-based predicates like that for bonds also. So you would be molecule pattern bond CS, bond length goes to.
But I think what we currently have is fine for this release.
Right, yeah. I'm just saying that.
Right. I think in the future we should consider having a lot. I mean, I don't see why you shouldn't allow 1, 2, 3, 1.5 here.
Okay, because we can use it with the adjacency matrix, the weighted adjacency matrix, but anything else than those values would be an error.
How do you get a weighted adjacency matrix?
So as a molecule property, it's called bond weighted adjacency matrix.
Okay. All right, fine.
Yep. And we should also include quadruple and 4, because those are legitimate bonds. I don't think quintuple is yet.
Right. I mean, so once I get a way to visualize those, once I make the rendering primitives for those, and I find some mol files that have quadruple bonds, then
possible. And then I think what we want to say here are single. Well, maybe we should say, I'm not formatting this correctly. Single bond, blah, blah, blah. It's not very exciting. We can just say double bond. Yeah, whatever. You get the idea. Oops. Right, you can fill that out.
Yeah.
Okay, I think I have to disappear, but I think we are in good shape here. Let me just look at your molecule.
Don't look behind the screen. There's nothing to see.
What do you mean?
I still have to rename a lot of those properties, is what I meant.
Okay. So you're going to de-experimentalize, defuturize these things. If we think annotatable is a word, we should add it to the spelling dictionary.
I sent an email to T-Spelling.
Okay. So I think, the most immediate thing for us to handle here, by the way, is probably getting, among other things, is linking this into machine learning by having some default feature extractor for molecules. I mean, at the very least, we could just get the adjacency matrix.
Right. So I actually have a few functions that make really nice feature extractors, but I have not gone through the motions or to make those net encoder. So I don't fully know the difference.
Okay, I think we agreed on that encoder will not be in this version for that.
All right.
But possibly exposing them as resource functions in the first for now.
Well, they will be done in 12.1. I mean, they will be in there. So
Okay, fine. But I think it'd be nice to just get it to do something. The machine learning stuff do something reasonable by default with molecules, even if those things are unfinished.
we did it this summer already. So we used some of the stuff already this summer. So
Well, so fine. Why don't we just install it? Why don't we silently install it so that machine learning just does something with molecules, even if we're not yet exposing the detailed feature extractors? Right now, it's going to fail on molecules, which doesn't do anybody any good. All right, we're going to go through some more of this documentation, but I think we're in great shape here.
Yeah. So I'll reach out to the machine learning people and see what we can hook up for 12.
let's finish this before the freeze.
Yes.
Right.
Good stuff, Bjorn. Yes.
No, it's Jason. It's all Jason and Robert.
I won't defuturize this because I think the wording has to change a bit. Okay, terrific. I will push these changes and talk to you all soon.
Thank you.
Right,
Great. Thank you.
See you all. Bye-bye. Bye.